Good morning. So you have quiz today, right? So last 20 minutes or last 25 minutes will be quiz. And it will cover chapter 1 and chapter 2. And there are total 6 questions. So 3 questions from chapter 1 and 3 questions from chapter 2. And most of them are multiple choice questions. And the quiz has been assigned through MyLab Statistics. So it will open at 11:55, I think, and it will close at 12:20. So you will have like 20 to 25 minutes to complete the quiz. Okay. Do you have any question? So today we'll try to finish section 5.2, 5.3. Yeah, that 2 sections. So section 5.2 is about events and sample space. So we'll discuss what is event, and we'll also go over some example. So sample space and event. Sample space is the collection of all possible outcomes for an experiment. And event is the collection of outcomes from the experiment that is a subset of the sample space. So what is the collection of all possible outcomes for an experiment? So let's consider an experiment. Flipping a coin. So if you flip a coin, then what are the possible outcomes? So a coin has 2 sides, right? Head and tail. So these are the possible outcomes. So the collection of all possible outcomes. Collections means you will use this notation. This is called the set notation, the curly bracket. So we use this bracket to represent a set or collection of elements. So you have to use this notation. Okay. So if we flip a coin, then we'll have 2 possible outcomes, either head or tail. So these are the collection of all possible outcomes. So in this case, the sample space will be S is equal, and sample space is denoted by S, and which is equal this set, the collection of all possible outcomes. So if you roll a die, so roll a die, then we'll have 6 possible outcomes, right? Then in this case, the sample space will be 1, 2, 3, 4, 5, 6. So this is the sample space. So what is event? Event is the subset of the sample space, any subset of the sample space. So for example, if S is our sample space and S is equal 1, 2, 3, 4, 5, 6, and if A is an event and which only consists all the odd numbers, then A will be 1, 3, 5. So this is the subset of S, right? Subset of this S. So this is called an event, and S itself, the sample space itself, is an event as well. So let's consider another event, B. If B is the even numbers, then the elements of the B will be 2, 4, 6, right? And similarly, for in this case, when the sample space S is equal just head or tail, if A is an event, just all hairs, then it will be just S. If B is the event of tails, then B will be just T, right? So events are the subsets of sample space. So if the event doesn't contain any element from the sample space, then that type of event is called null event or empty set. So for example, if E is an event and for this sample space, and this is the number greater than 7, greater than 7. So there is no number in S which is greater than 7. So this is empty set or null event. So in this case, we represent this event as E is equals to, this is called empty set. This is called phi. So this is phi. So this is empty set or null event. But if we cannot write this, actually, we cannot write this like this. If you write the null event like this, that means this is not a null event. This is an event with element phi. So you have to write either this way or this way. This is means also a set with no elements. That's mean empty set or null event. Do you have any question? So the sample space is the collection of all outcomes, and event is the subset of sample space. Yeah, that's the main idea. So we'll go on an example, how to find the sample space. So how do we find the sample space? Here we will discuss two different ways. There are some other way as well, but we are not going to discuss that. So we'll only discuss this two way of finding sample space. So to list all the possible outcomes, you can list all the possible outcomes. That's what we did in the previous example. And or you can create a tree diagram to find the sample space. So here is an example where we listed all the possible outcomes, flipping a coin and rolling a die. So here the experiment is you will flip a coin and roll a die together. So first you will flip a coin, then you will roll a die, and that is the complete experiment. So this is just a single experiment. Now we have to find all the outcomes. So how can we find the sample space? We can list all possible outcomes. So what are the possible outcomes? So from flipping a coin, we'll get either head or tail. And from rolling a die, we'll get 1, 2, 3, 4, 5, 6. 6 numbers, right? So the outcomes, if the first outcome is, sorry, if the from the flipping a coin, if we get a head, then there are 6 possibilities, right? We can get head and number 1, head and number 2, head and number 3, head and number 4, head and number 5, head and number 6. So these are the possible outcomes for head. Heads and 1, heads and 2, heads and 3, heads and 4, heads and 5, heads and 6. Similarly, we can get tails and 1, tails and 2, 3, 4, 5, 6. So we have total 12 outcomes. So you will list all the possible outcomes, and that will be our sample space. So our sample space is equal here, head 1, head and number 2, head and number 3, head and number 4, head and number 5, head and number 6, tail and number 1, tail and number 2, 3, 4, 5, 6. So there are total 12 outcomes. So this is our sample space in this case. So we listed all the possible outcomes. And for the same example, we can also construct tree diagram to find the sample space. So what is tree diagram? So this type of diagram is called tree diagram. So here, first you will draw a diagram for flipping a coin. From flipping a coin, we'll get 2 outcomes, H or T. So we have actually 2 branches. One branch for head and second branch for T. Now you will roll a die. So we already flipped a coin. So we are done with this. So for example, if our first outcome is head, now we'll toss a coin, right? Sorry, we'll roll a die. So we already have this outcome, and we will roll a die. Then we'll have 6 branches here, right? because from rolling a die, we'll get 6 outcomes. Then it could 1, 2, 3, 4, sorry, 4, 5, 6. And similarly, for example, so if we consider that the first outcomes from flipping a coin is tail, then for this case, we'll have also 6 outcomes here, right? 1, 2, sorry, 2, 3, 4, 5, 6. Okay. Now you can list all the outcomes: H1, H2, H3, H4, H5, H6. So here you can see. So this is our all possible outcomes. So how many outcomes total we have? We have total 12 outcomes here. So this is the sample space in this case. So either you can list all the possible outcomes, or you can construct a tree diagram to get all the outcomes and define the sample space. And each outcome in the sample space is called sample point. So here we have 12 sample points. Okay, so why 6 outcomes? Okay, yeah, good question. So what we are doing in the experiment, our experiment is we are flipping a coin and rolling a die. So that's our complete experiment. So if you flip a coin, you have like 2 choices, 2 options, either head or tail. And we are assuming that first outcome is head. Then we roll a die, right? And a die has 6 sides. So that's why we'll have 6 outcomes. And each side is numbered as 1, 2, 3, 4, 5, 6. So if you roll a die, either you will get 1 or 2 or 3 or 5 or 6. So that means there are 6 possibilities. So that's why we are getting 6 outcomes here. And similarly, if the first outcome is tail, and if you roll a die, you have 6 possibilities. Is that answer your question? Okay, thank you. Any other question? So we'll go over some more examples. The first one is tossing a coin. So that's mean we have like 2 outcomes. So sample space is HT and E equals to H. This is the subset of sample space. So this is an event. So tossing a die, the rolling a die, the sample space will be 1, 2, 3, 4, 5, 6. And E is the even numbers 2, 4, 6, which is an event, right? Even if you consider E is odd number, then it will be 1, 3, 5. And example 3, tossing a coin twice. So if you toss a coin twice, what will happen? So you can get, in the first toss, you can get head, and second one also head. First one head, second one tail. Then first one tail, second one head. First one tail, second one also tail. So that's the all possibilities. So we have 4 outcomes if you toss a coin twice. Then the sample space will be S is equal this one. So now if you consider E is equals to at least 1 head, or you can consider the first outcome is head. If the first outcome is head, then it will be H, H, and HT. We have only 2 outcomes, right? So this is an event. Or at least if you consider an event A, which is at least 1 head, at least 1 head means H, 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 T, H, and H, T. So we'll have 3 outcomes. So this is also an event. Okay, the sample space is usually we denote it by S, and events are denoted by A, the capital letter, A, B, C, E, D, or other letters. Example for tossing a die twice. So if you toss a die twice, then you will have total 36 outcomes. You will get 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6. So if in the first roll, if you get 1, then in the second roll, you have 6 possibilities. You can get 1, 2, 3, 4, 5, or 6. So that's mean for each outcome, you will have 6 possibilities. Each outcome of the first roll, you will have 6 possibilities for each one. That's mean you will have total 36 elements in the sample space. So the sample space is denoted by this one, or you can list all the outcomes. So example 5 is choosing a point from the interval. Now we do not have any discrete outcomes. We have continuous interval, continuous outcome. So this is, we have infinite number of elements in the sample space. This is 0 to 1. That's mean any number between 0 to 1 is the sample point in this case. So if you consider 0.5, this is a sample point. If you consider 0.6, this is also between 0 and 1. You can also consider 0.01, 0.002. This is also between 0 and 1, right? So that's mean any number between 0 and 1 is the sample point in this case. So we have infinite number of sample points in this case. So the sample space will be 0 to 1, and any subset which is between 0 to 1 will be an event in this case. So we considered an event, and where this is also an interval. This is from 1/3 to 1/2. So this is between 0 and 1, right? Both numbers are between 0 and 1. So this is an event. This is also an interval. Do you have any question? Is example 5 clear to you? Okay. So we can represent the event with a Venn diagrams. So Venn diagrams for an event. So the first one is not E. So that's mean the elements which are not in E. This is called the complement of an event. So if E is an event, so we usually in Venn diagram, we use rectangle for sample space. So this is our sample space. And for the events, we use circle. If E is an event, okay. So this diagram means this rectangle is the sample space, and this circle inside the rectangle is a subset, right? Because this is inside the rectangle, inside the sample space. So this is a subset of S. So this is an event. E is an event. And we shaded the outside region. We shaded this region. So that's mean we are considering the event which is not E. This is called complement of E, or this is also denoted by E prime or complement of E. That's mean all the elements in the sample space which are not in E. And the second diagram is for the event A and B. What is A and B? This is also denoted by A intersection B. This is called intersection. That's mean only the common elements between A and B. So in this case, the common region is this part. So that's why we shaded this region. So this is our sample space, the rectangle. This is our sample space. And we have two events and they intersect each other. That means they have some common element. And this is the common region. And here A or B. So either in A or B, or A and B both. So that's mean this whole region. This is A or B, or we can also write this one as A union B. This is called union. That means all the elements which are in A or in B or in both A and B. So this is called A union B, or you can also read as A or B, A or B, or this one you can read as A and B or A intersection B. Do you have any question? No question? Or you're not listening the lecture?
No questions.
Okay, thank you. Okay, so relationships among events. So we already discussed relationship among events, not in E, A and B, and A or B. So now we'll go over some example. So for example, if our experiment is rolling a die, then the sample space will be 1, 2, 3, 4, 5, 6. And A is an event which consists all odd numbers. And B is an event which has 1, 2, 3, 4. Okay, so now we have two events, A and B. So odd numbers mean the elements are 1, 3, 5, right? Okay, so the first one is not E, or we can say not, here we do not have E, maybe we consider not A. An event which is not A. Not A means a complement. That's mean A prime. So what are the elements in A prime or a complement? Okay, so which element should be in A prime? Anyone? So I got a couple of answers. Even numbers. Okay, then B, 1, 3, 5. Okay, even numbers. Even numbers. Okay. Yeah, many of you got correct answer. Yeah, it should be even numbers, right? Because the event A is odd numbers, right? 1, 3, 5. So A prime, this is we you can read as, oh, I'm sorry. This is, you can read as A prime or A complement. So it will be 2, 4, 6. That's mean all the elements in the sample space which are not in A. This is called A complement, or you can say A complement. So this is 2, 4, 6. Okay. So now A and B. So A intersection B. So what are the elements in A intersection B? Anyone? Okay, so I got one answer, 1 and 3. While within A and B. One and three. Okay, 1 and 3, 1 and 3. Yes. So what are the common elements in A and B? 1 and 3. Yeah, that's correct. Perfect. So 1 and 3. So what should be A union B? A union B. Anyone? Or you can say A or B. So what should be the elements in this event? Anyone? All numbers? Okay. So look at A and B. So A is 135 and B is 1, 2, 3, 4. So A or B means, or A union B means all the elements which are in A or in B, or either A and B both. Okay, so 1, 2, 3, 4, 1, 2, 3, 4, 5. How about others? Anyone else? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, and 2, 4, 5. Okay, so some of you, I found some correct answer, 2, 4, 5. So why do you think it is 2, 4, 5? Yeah, many of you say 2, 4, 5. Any explanation why it is 2, 4, 5? Okay, so A union B. That's mean the numbers which are in A or in B or in both. Okay, so maybe you thought that the numbers which are, okay, so actually who answered 2, 4, 5, they thought that like it is complement of A intersection B. Actually, this is not true. A or B means either in A or in B or in both. So that's mean you have to list all the numbers here. So what are the numbers? 1, 2, 3, 4, and 5, right? So 1, 2, 3, 4, 5. So this is the union or A or B. Is it clear? Yeah, even though they share on 3, you have to also consider them. Yeah. Okay, thank you. So is it clear now? What is A union B or A or B? Okay, thank you. So mutually exclusive events. So what is mutually exclusive means? Mutually exclusive means if two events do not share any common outcomes, do not share any outcomes. So that's mean if you consider the sample space 1, 2, 3, 4, 5, 6, and A is an event which are just odd numbers 1, 3, 5, and B is an event which are even numbers 2, 4, 6. Do they share any outcome? They do not, right? So that's mean A intersection B. So what is A intersection B in this case? So could you please answer A intersection B with the set notation? That's mean with this notation. Anyone? So what should be the elements of A intersection B in this case? Okay, so I got one answer. Okay, so A intersection B or A and B means only the common elements between A and B. Is there any common element? No. Yeah, it should be null event. Yeah, it should be null event. So how do we denote null event? I'm sorry. So we denote the null event, either you will write this or you can also use this. but never use this notation to represent null element. Never use this one, because this doesn't mean null. This means it has an element which is phi. So never use this one. Either you will use this notation or this one. Okay. Thank you. So this is, since A intersection B is empty, they do not share any element. This type of events are called mutually exclusive events. That means they do not share any element. So if two events are mutually exclusive, using the Venn diagram, we can represent this. Event A, and this is sample space, and this is event B. So you can see that A and B are separate. They didn't share anything. So this type of events are called mutually exclusive event. You need actually this idea when you will be finding the probability for set operations. Okay, here you can see this one is mutually exclusive and this one are not mutually exclusive. So this is non-mutually exclusive events and this is mutually exclusive events because they share some elements, right? They have some common part. So this is not non-mutually exclusive events. Okay, so there are three events, A, B, C. The first one, so which one is mutually exclusive here? The first one, right? Mutually exclusive. I think, yeah, the first one is mutually exclusive, right? Because they didn't share anything. They didn't share any element. So that's why they are mutually exclusive. So this one is mutually exclusive events. A, B didn't share anything. B, C didn't share anything. C, A didn't share anything. So that's mean, so when you have more than two events, you have to consider all pairs to determine mutually exclusive events. You have to consider all pairs. So you have to consider AB, then BA, then AC. So if this is mutually exclusive, this one is also mutually exclusive, this one is also mutually exclusive, then you can say A, B, C are mutually exclusive. So here is AC that didn't share, AB that didn't share, BC that didn't share anything. So that's why A, B, C are mutually exclusive. Here, AB shared some pairs, BC also shared some pairs, and AC also shares some elements. So that's why they are not mutually exclusive. And here they are not also mutually exclusive. Though we have two pairs which are mutually exclusive. If you consider AC and BC, they are mutually exclusive. That's fine. That's true. If you consider pairwise, yeah, they are mutually exclusive. They are mutually exclusive. But ABC together, they are not mutually exclusive because we have one pair which is not mutually exclusive. This pair is not mutually exclusive. So that's why ABC are not mutually exclusive. But if you consider this pair and this pair separately, yeah, they are mutually exclusive. That's true. Is it clear? Okay, great. Okay, some rules of probability. So now we'll go over the probability rules. So the first one is, if E is an event, then P of E. This notation is called the probability of E. So if A is an event, then P of A is called probability of A. That's when probability of this event. This is probability of event E. So this is the notation. So now if S is a sample space which is 1, 2, 3, 4, 5, 6, and all the outcomes are equally likely outcomes. That's mean each one has equal chance. And A is an event who is at odd numbers 1, 3, 5. Then what is the probability of A? So what is the probability of A? Okay. So what do you think? What should be the probability of A? Anyone? 1/2. Okay. 1/2. So do you agree the probability is 1/2? Okay. Yes, 1/2. This is correct answer. So that's mean the number of how do we calculate the probability? You can also use this notation, the number of elements in A. This is called N of A. N of A means number of element in A, and number of element is S. That's mean the total number of outcomes in A divided by the number of outcomes in S. So how many outcomes we have in A? We have 3 outcomes in A. And how many outcomes we have in S? We have 6 outcomes in S. So the probability is 1/2. Yes, that's correct. So the first rule is the complementation rule. So we've already discussed the complement event or complement of an event. So if E is an event, then the complement is all the elements in S but E. That's the complement of E. So in case of probability of E complement is equal 1 minus probability of E, or probability of E is equals to 1 minus probability of E complement. So how does it work? So let's consider the same sample space. So 1, 2, 3, 4, 5, 6. So let's consider the event A on 3, 5. So what was the probability of A? Probability of A in the previous example, it was 1/2, right? So what is complement of A here? So what is A prime here? So what are the elements in A prime? Anyone? So you already know this one, right? So 2, 4, 6. So now if you calculate the probability of A prime, then it will be 3/6, which is 1/2, right? Yeah, this is one way you can calculate the probability. But you can also simply calculate the probability of an complement event. If you know the probability of the given event, so probability of A is 1/2, we already know this. So you can easily calculate the probability of A prime, which is 1 minus probability of A. That's mean 1 minus 1/2, which is also 1/2, right? So this is correct. So why does this work? Because we know that the total probability is 1, right? And the complement is all the elements outside A. So that's mean if you consider A and A complement, that includes all the outcomes in the sample space. That's why it does work. The complement is total probability minus the probability of that element. That's mean 1 minus probability of A. Okay, so now I'll go over an example. The first one is, let the event A be getting the flu this winter. We are given probability of A is 0.43. The event not getting the flu is a complement. Okay, so probability of A is equals to 0.43. And probability of A complement is equals to 1 minus probability of A. That's mean 1 minus 0.43. So that's means 0.43. 0.57. So this is the probability of not getting the flu, right? Okay, so even if you think in that way, so there is only two options, right? Either the people will get flu or will not get flu. So that's mean the total probability is 1. So if you add the probability who got flu and who didn't get flu, if you add this to probability, that should be 1, right? So that's why 0.43 plus 0.47, sorry, 0.57 is 1. Okay, the second example is a bag contains red and blue cards. Okay, so a bag has only red cards and blue cards. The probability of drawing a red card is 2.5, sorry, 2 over 5. So probability of drawing a red card is 2 over 5. So what is the probability of drawing a blue? So what do you think? So what should be the probability of blue in this case? Okay, so I got 2 answers, 3 over 3, 3 answers, 3 over 5, 3 over 5, 3 over 5. Okay. So anyone else? Or any other answer? Yes, 3 over 5. Yeah, that's correct, 3 over 5. Because it said that a bag contains only 2 types of balls, right? Red and blue. So the complement of red is blue. And we know that the probability of red is 2 over 5. So the probability blue is the complement of red. So that's mean 1 minus probability of red, right? So that's mean 1 minus 2 over 5, which is 3 over 5. Actually, you will be using this rule a lot, the complementation rule, because it will make your life very easy. Because sometimes it is really time consuming and really hard to find the probability directly. So in that case, you can use this complementation rule and you can find the probability easily. Okay, the next rule is addition rule. So what is the addition rule? Probability of A or B. This is also can be denoted as A union B. They are same. So A union B or A or B, what does it mean? That's mean either in A or in B or in both, right? So that's mean this part, the green part, the red one, and the orange one, right? So this is the, so what is the, so this one is A, this one is B, and this is sample space. And this part is the intersection of, this is A intersection B. Okay, so now this one can be written as probability of A plus probability of B. Okay, now the question is it correct? Probability of A union B, that's mean probability of this region is equal probability of A plus probability of B. Is it correct? What do you think? Is it correct? Yes or no? Okay. So some of you think that this is correct and some of you think that this is not correct. So okay, let me explain it. So what does it mean by probability of A? Probability of A means probability of this part, right? Yeah. Look at this picture carefully. Probability of this part is the probability of A, right? So this included this region, also this region, right? Okay, this is probability of A. Now consider probability of B. So if you consider probability of B, that's include this region, right? So that also includes this region, right? Probability of B. Okay, so what did we do? When we considered probability of A, we considered the common region already, right? This region already we considered, right? When we considered probability A. Now, when we are considering probability B, we are taking the common part again, right? So that means we are adding the common part twice. But probability of A or B is this region, this one, and this one. Let me draw the picture again. So probability of A or B means this region, this one, and this one. So this is maybe, yeah, this region and this region and this region. But when you are considering A, you are adding this part. When you are considering B, you are adding this part again. So that means we are adding the common part twice. So that's why we need to subtract the common part once. And that will give us the probability of A union B or A or B. Is it clear? Why we subtracted the common part? Okay, good. So here is examples. First one is flip a coin twice, and A is the both are same, and B is at least one head. Find the probability of A union B. So what is the sample space in this case? The sample space is H, T, TH, and TT. So this is our sample space. So the event A is both are same. So that's mean this one and this one, right? And what is event B? This is at least one head, at least one head. Yeah, this is the event B. So now we'll find the probability of A union B. So what is probability of A? This is 2/4, which is half. And probability of B is 3/4, right? Now, what is the intersection of A and B? This is how many elements we have in A intersection B? Anyone? So what is A intersection B? So what are the elements in A intersection B or A and B? Anyone? No, I'm not asking. Okay, let me clear it. Yeah, I'm not asking about the probability. Yeah, the probability is correct. 1/4. Yeah, that's correct. I'm asking about the, yes, all head, right? Yeah, the intersection is all head. Yeah. Because we have HH here, we have also HH here, right? We have just one element in common. So A intersection B is, sorry, probability of A intersection B is, yeah, the probability is 1/4. Yeah, that's correct. Okay, now we need to find the probability of A or B. So probability of A union B is equal probability of A plus probability of B minus probability of A intersection B. So that is 1/2 plus 3/4 minus 1/4. So then it will be 5 minus 1. It will be, I think, 4/4. This is 1. It is 4/4. Yes, this is 4/4. Okay, so this is one way. So you can use the probability rule to calculate the probability, or you can use, or you can find the sample points for A union B. So if you consider A union B, then it will be this one, this one, this one, and this one. So that's mean you will have 4 outcomes. So the probability of A union B will be then 4/4, and which is 1. Okay, so let's consider the second example. A equals to odd numbers, so that's mean 1, 3, 5, and B is you have to find the probability of A intersection B and probability of A union B. Okay, so this is homework for the next class. Homework means actually I'll not give you any grade for this one, but I'll ask you the answer in the next class. Okay. Okay, so I'll stop here and I'll give you the quiz now.